Hey everybody, welcome back to Honors Geometry. Today we're going to cover 10.2 congruent chords. First off, a theorem. If two chords of a circle are equidistant from the center, then they are congruent. So here we have CD, that is a chord, and AB, that is a chord. They are both equidistant to our center O, as you can see. So what we're able to conclude from that is chord AB is congruent to chord CD. Okay, moving on to our second theorem. If two chords of a circle are congruent, then they are equidistant from the center of the circle. So here we have chord BD, here we have chord EC. If those two are congruent, we know that they must be equidistant to the center, which is A. And remember, the shortest length from any 2 points is going to be the perpendicular segment. So the shortest distance from A to chord BD is going to be that perpendicular segment. Same thing here. The shortest distance from point A to chord EC is going to be that perpendicular segment. So that is why these form a perpendicular intersection. And the same thing would be happening up here as well. All right, example 1. Pause the video and try this one out on your own. Given Km is congruent to Kn, now that's not enough for us to know that these two segments are equidistant from the center. This next given information lets us know they're equidistant. Km is perpendicular to DE and Kn is perpendicular to FG. Because we know these are perpendicular segments, that lets us know that Km is the shortest distance from the center to the chord, and Kn is the shortest distance from the center to the chord. So that perpendicular part is important. It lets us know we have the shortest segment from the center to that chord. So there you see that these segments Km and Kn are equidistant, are congruent, and also perpendicular to our chords. Therefore, these chords are equidistant to the center. So what do we know about these chords? We know the chords are congruent, which comes in handy because we're told that DE is x plus 2 and FG is 2x minus 4. Those are the lengths of our chords, so we know that DE is congruent to FG, so we can set these equal to each other. All right, so x plus 2 equals 2x minus 4. We solve and we get x equals 6. We're asked to find the radius of circle K, and we're also given that MK is equal to x over 2. Well, if MK is x over 2, MK is 6 over 2, which is 3. So here you say MK is 3. Now that's not our radius. Let's draw in the radius. So here we've drawn in our radius. We have Km is 3. We can find dm. All right, we know dE because we know x equals 6. So 6 plus 2, dE is 8. So the entire chord is 8. What does dm have to be? It has to be half of that. We learned that last lesson, that when a chord intersects with the perpendicular segment from the center, that perpendicular segment, which is Km in this case, is going to bisect our chord. So 4 is dm. So we're asked to find the radius. 3, 4, KD has to be 5. That's a 3, 4, 5 right triangle. There you go. The radius equals 5. Moving on to example 2. ORANGE, orange is a regular hexagon inscribed in circle C. A, find the measure of angle GCE. Pause the video now and try that on your own. Okay, we're going to have 6 congruent triangles on the interior of this hexagon here. So each of these central angles are going to be congruent to one another. So ask yourself, how many total degrees are there at the center of this figure? Let me watch the path of my cursor. It goes around. It's 360, right? So 360 divided by how many central angles do we have here? We have 6 of them, right? There's 6 of these triangles. We only see one of them, but there are 6 of them that I could draw in. So 360 divided by 6 is 60 degrees, and the measure of angle GCN is 60 degrees. B, find the radius of circle C. Pause the video if you haven't done this yet and try that now on your own. You should know this is going to be in terms of x. So if you unpause the video wondering how you're going to do this, it is in terms of x. And to further clarify this, this central angle of 60 degrees has been bisected when I draw in the altitude. So we have a 30, 60, 90 right triangle. So let's call this shorter leg here x. So x is going to be our shorter leg there. All right, so go ahead and find the radius now in terms of x. Well, the radius is going to be the short leg, right? So in our 30, 60, 90 right triangle, the short leg is x. We're trying to find the hypotenuse. To go from the short leg to the hypotenuse, we multiply by 2. So the radius is 2x. All right, and finally find the distance from C to GN. This is the perpendicular segment from the center C to GN. Therefore, that is the shortest segment. So find that distance now. And it is going to be x multiplied by square root of 3. All right, thank you very much.